Hi, it's Chris from FlipMath. I'm going to take you through today's little bit, and it is on the factor and remainder theorem. And I'm going to take you through a couple of examples, and these are from the homework itself. Okay, so let's get started. This is part of the C1 module for AS Maths, and you should have worked through the stuff that we've done previously. If not, you'll be able to. Okay, we're going to prove whether 2x minus 1 is a factor of 8x to the 4 plus 2x cubed minus 11x squared minus 2x plus 3. If this is a factor, if I was to solve this bracket equal to naught, so I would solve 2x minus 1 equal to naught. I would get 2x is equal to 1 because I'll bring my minus 1 over the other side. So I'll bring my minus 1 over the other side, so that it becomes a plus 1. And then I'll get x is equal to a half. So that's the solution for that factor if I solved it equal to naught. The factor theorem says if I replace x with a value, and the value of the expression, like we have here, is equal to naught, then that solution gives a factor. And the way we usually write this is not as f of x, but f of some value a is equal to naught. If that is equal to naught, then x minus that number a is a factor. So it should save us a little bit of work, because we could do division of polynomials to do it. So we're going to check to see whether f of a half gives us naught. Now all I'm going to do is I'm going to replace every x in the equation with a half. So I have a half to the power 4 there, plus 2 times a half minus, half cubed, minus 11 times a half squared, minus 2 times a half, plus 3. Okay, so a lot to be putting in here, but let's make it a bit bigger for ourselves. So I'm going to write a quarter to the power of 4. And a quarter to the power, a half to the power of 4 means a half times a half times a half times a half. And if I multiply 1 times 1 times 1 times 1 on the top, I get 1. And if I multiply 2 times 2 times 2 times 2, etc., I get 16. So up here, I have that a half to the power 4 will be 1 over 16. All good so far. Then if plus 2 times a half to the power 3, and you can refer to the bit below, so it's 3 of these multiplied together, so it'll be half times a half times a half. And if I do that, and I do it correctly, I'll get an 8th. Close the bracket. Then I have, minus 11, and it should be times a half squared. And when I do a half squared, I will get a quarter. And then if I do 2 times a half, or minus 2 times a half, I'll get minus 1, and then I'll just have my original, which is plus 3. So I'm going to tidy this up a little bit. 8 times 1 over 16 is 8 over 16, and 8 over 16 gives me a half. Then if 2 times an eighth is 2 eighths, which simplifies down to give a quarter, then we have minus 11 over 4, and then minus 1 plus 3 gives me plus 2. Well, I'm going to group together some of these things. I can even do it together. So a half plus a quarter is 3 quarters. I'm going to keep the minus 11 over 4 here. And I'm going to turn the 2 into quarters because, you know, why not? 2 into quarters is 8 over 4. And you'll see that if you add together 3 over 4 and 8 over 4, I'll get 11 over 4, which when I take away 11 over 4, does indeed give me naught. Therefore, I can say that 2x minus 1 is a factor of our expression above. Okie doke. So next type of question, or common question we'll get, is to fully factorize the following, and I give you one factor. So I'm going to give you, again, the factor 2x minus 1 is a factor of 2x cubed minus 5x squared minus 4x plus 3. And usually the first part of this question is to prove exactly what we did beforehand, which is, use the factor theorem to prove that when I put f of a half in here, I will get 0. Except in this case, we're going to have done that. I've got to get the rest of the factors. So if I do that, what I'm going to do is I'm going to write down myself a little polynomial division sum. So if 2x minus 1, and I'm going to divide it into 2x cubed minus 5x squared minus 4x and plus 3. Okay, so the first thing we're going to look at is our power of x in the first bit. So how many 2x's go into 2x cubed? I'll do a little sum down the right hand side here. So if you really are stuck and can't think, I'm going to take my 2x cubed and divide it by 2x. And you'll see that 2 divided by 2 should cancel. And x cubed divided by x will cancel to give me x squared. So I can therefore write that how many 2x's are in 2x cubed, or what do I need to multiply 2x by to get 2x cubed? I need to multiply it by x squared. And once I've done that, I'm going to multiply the x squared that I've got by my original bracket on the left here, the 2x minus 1. And if I do that, I have 2x, or x squared times 2x gives me 2x cubed. And then I have minus 1 times x squared, which is minus 1x squared. And what I'm going to do is I'm going to stick that in down below here. So I'm going to stick in my 2x cubed minus my x squared. And what I'm going to do is I'm going to take one away from the other one to see what I've got from a remainder. So 2x cubed minus 2x cubed is nothing. And minus 5x squared minus x squared is minus 5x squared plus x squared, which is minus 4x squared. And then I'm going to do the same thing as I did before. So I'm going to see how many 2x's go into 4x squared. And I can do the same process again, but if I do that, I will find that it is minus 2x. And if I do my little somewhere, do minus 2x, I'm going to multiply it by my original bracket now. So minus 2x multiplied by 2x minus 1. I will get minus 2x times 2x is minus 4x squared. And then minus 1 times plus minus 2x gives me plus 2x. And I'm going to write that in down below. I'm going to minus 4x squared and I have plus 2x. Now you shouldn't forget to bring down your next term because you'll see that it lines up. But I've got a minus 4x here. And I am going to subtract these. Obviously the minus 4x squared and the minus 4x squared will cancel to give me naught when I subtract them. And then I'm going to have minus 4x minus plus 2x. And minus 4 minus 2 gives me minus 6x. And I have one more step to go. So if how many 2x's are in 6x, or one of them would multiply 2x to get minus 6x, I'm going to get minus 3. And then I'll do minus 3 times, oops, should probably make that black just so it's consistent, times my 2x minus 1 again. And that'll give me minus 6x, and minus 3 times minus 1 is plus 3. I'm going to write this in down below, so minus 6x plus 3. I'm going to bring down my last term here, which is plus 3. And then when I take them away to see what remainder I've got, I'm going to have minus 6x plus 3 minus 6x plus 3, and that will give me no remainder, which is exactly right, because if that is a factor, then we should get no remainder. The last thing we've got to do, now that we've checked that, is factorize the expression that we're left with up here. So we're going to factorize x squared minus 2x minus 3 into our pair of brackets. And we're looking for the pair of factors that multiply together to give you minus 3. If I write down my factors on minus 3. And I'm going to see which of those add together to give me minus 2. Well, when I add those two together, I get minus 2. When I add together those, I get plus 2. So the factors that we're looking for, are the minus 3 and the plus 1. So if I fill in my factors, so it's going to be x minus 3 in the first bracket and x plus 1 in the second bracket, and therefore I can say the factors of the polynomial are 2x minus 1, then x minus 3, and x plus 1. And if you have time left to get at the end, you can check by multiplying out those pair brackets or triple brackets to see that you get the original expression, the 2x cubed minus 5x squared minus 4x plus 3. If you want to see more, go on to flipmap.co.uk and search for factor theorem or remainder theorem, any of those, in the box near the top of the website. And all feedback and resources should go to @flipmath, or you can get me by email if you're in class. Okay, I'll catch you next time. Bye.